So, good evening once again to all professors for the third day first session. Uh, Today, first session going to the topic is carbon capture in CA engine, combustion ignition engine. Professor S. Murugan, Department Professor, Department of Mechanical Engineering, National Institute of Technology, Rourkela, Odisha. Actually, he is a very nice person to approach him for anything. He is a kind person. I think fixed topic immediately asked for foreign examiners. He has given a clue to fix the foreign examiners and also for assisting in many things in many ways. So today is carbon capture is one of the carbon capture storage technology. It is also to reduce to greenhouse gas emission. So CO2. It is nowadays globally CO2 reducing emission is somewhat crucial way to reduce because it affects many things. Environmental effect. We know how this affects and all. Some 5 years back we have got corona. No? So because of this reason, CO2 emission available, plenty of CO2 emission available in the atmosphere. Because of the reason, we got various effects, climate change, flood situation, everything is coming. CO2 particle, a particle can live up to 200 years. See that, what is strength of the CO2 particle. The CO2 particle can live up to 200 years. So we have to use carefully. That is what we are all switch over to renewable energy sources. It is one of the topic we are going to see. Professor Dr. S. Murugan sir is going to talk once again. Carbon capture in CA engines. Sir, welcome you, sir. Welcome you because behalf of St. Peter's College of Technology and the team of Mechanical Engineering Department. Welcome you once again, sir. Welcome.
Thank you. Thank you.
So, Dr. HOD Mechanical Department is going to introduce about him. Dr. Satra, Jayasekaran.
Speak.
Hello.
Can you hear me?
Yeah.
Yes, sir.
Audible,
Yes.
Satra.
Thank you,
Yes,
sir.
audible, sir.
It is an honor to introduce Murugan, Professor of Mechanical Engineering at National Institute of Technology, Rourkela. Dr. Murugan has dedicated over 32 years to the field of mechanical engineering, contributing significantly to research areas such as waste to energy, renewable energy, biochar utilization, carbon capture, combustion, and automotive engineering. His extensive work, including more than 130 research publications in reputed international journals and 70 conference papers, has garnered over 6,900 citations, earning him an impressive Google Scholar. Dr. Murugan's contribution extends beyond publications as he has successfully supervised 10 PhD scholars, mentored numerous postgraduate and undergraduate students, and led major research projects sponsored by the Government of India. He has also made remarkable strides in innovation, filing 5 patents, one of which has already been granted, recognizing among the top 2% scientists by Elsevier and Stanford University for 3 consecutive years since 2021. His expertise in energy and sustainability is truly commendable. Today's session aims to explore the role of carbon capture technologies in environmental impact. With the ever-growing concerns surrounding carbon emissions and climate change, it is imperative that we engage in discussions that drive discussions and collaborative learning. Let us make the most of the opportunity. At this outset, I would like to extend my heartfelt gratitude to the distinguished speaker who enlightening section on carbon capture in CI engines environmental effect. Your presence here today reflects a shared commitment to addressing one of the most global challenges, reducing carbon emissions from the combustion engines and advancing sustainable energy solutions. And I look forward to an engaging and enriching session ahead. Welcome you, sir. Now the session is yours.
Thank you very much, Dr. Jayashekhar, head of the department. I also thank Dr. CHINNAPANDIAN, Professor of Mechanical Engineering, and Dr. K.
Thank you, sir.
Purushothaman, Professor of Mechanical Engineering, to give me this opportunity to deliver my lecture in front of this august audience. Despite it is very late evening, means 6 o'clock is normally for late for us, late evening. Despite that, 82 participants uh, are, of course, attending this one way. It's a good sign that Atal FDP is, of course, attracting many participants in the nation. So, with this note, I'd like to start my lecture. Is it audible?
Yes, sir. Audible,
Is it
sir.
audible?
Yes, sir.
Yeah.
Yes,
Is it
sir.
audible, sir? Clear, sir.
Yes, sir.
Yeah. So, my topic is carbon capture in CA engines. So, in recent years, we have been continuously experiencing the climate change. In some parts of the world, there is enormous change in the climate, like hike in temperature, low in temperature, high rainfall, low rainfall, drought, very cold, like this. That is because of the term called climate change, which is the consequence of global warming. Everybody know the consequence of global warming, and the causes of this global warming is that because of continuous accumulation of carbon dioxide in the atmosphere. We all know that there are different greenhouse gases, what we call it as GHG, greenhouse gases. So greenhouse gases can be given in two forms. One is natural greenhouse gases, which consists of water vapor, carbon dioxide, methane, and ozone. On the other hand, greenhouse gases emitted or generated by human activities. Normally, we call it as anthropogenic activities. Called under that we have different emissions like carbon dioxide, different greenhouse gas emissions called green carbon dioxide, methane, nitrous oxide, and of course halocarbons like CFC, HCFC, use of CFC, HCFC, HCFC, PFC, like that. So these greenhouse gases impact our inner environment, particularly the accumulation, continuous accumulation of carbon dioxide and methane in the ground, methane in the ground, and carbon dioxide in the atmosphere. It increases the global temperature, global average temperature, 1 degree Celsius for every 10 years. As a result, of course, now we notice the atmospheric temperature. It goes even up to 55 degrees Celsius in India. Even in last year, of course, Europe experienced a very high temperature in summer, that is around 35 degrees Celsius, which never experienced by Europeans. So this continuous increase in temperature, atmospheric temperature, that is the result of the continuous accumulation of carbon dioxide in the atmosphere. So people are working on to reduce the accumulation of carbon dioxide in the atmosphere. There are many sources for carbon dioxide emission arise from different combustion devices or sources. The main one is that the, the carbon dioxide emission originate from vehicles, especially vehicles and heat engines. Many people are working on, of course, to reduce this carbon dioxide which come out from automotive vehicles and heat engines. Despite that, we are unable to cut down this carbon dioxide in a significant way. If you see this heat engines, there are two heat engines based on the nature of air fuel mixture which burns. One is called external combustion engine and the second one is internal combustion engine. Again, as all of you know that internal combustion engines can be classified into two based on the method of ignition. One is spark ignition and the second one is compression ignition engine. Petrol engines or gasoline engines, of course, they are example of spark ignition engine, which are mainly used in passenger vehicles. They are lightweight, high-speed engines relatively to compression ignition engines. Compression ignition engines, they are mainly used in automotive vehicles, decentralized power generation units, standby power generation units, which are required in hospitals, education institutions, like that. So, not only this, ICE engines, they release carbon dioxide emission. External combustion engines also, they release carbon dioxide emission. Like power plants, coal-fired power plants and all, we get a lot of carbon dioxide emission. The main worry of the world is that the mobility vehicles called automotive vehicles, they release carbon dioxide continuously, but that cannot be captured because automotive vehicles continuously run on the road. It is not stationary. Therefore, it is very difficult to capture carbon dioxide from automotive vehicles. But it is possible to capture carbon dioxide which is released from stationary engines or stationary power plant. People are working on both ways. Many people focus their research on controlling CO2 emission or capturing CO2 emission in coal-fired power plant or gas turbine power plant, like that. In addition to that, of course, they focus on controlling CO2 emissions, released CO2 emissions in cement industry, steel industry, of course, oil refineries, like that. But my research, it focuses on capturing carbon dioxide in compression ignition engines. In compression ignition engine itself, as I told, this C engine can be used, C engines are used in automotive vehicles which are not stationary, they are mobile, but C engines are used in standby power generation units, agricultural engines, or the the heavy vehicles, I mean off-road vehicles. So in that case, whichever the C engines used in power generation, that can be focused to control CO2 emission. By the way, at least we can capture 10 up to 10% of CO2 emission originate from C engines. That is the idea. We focus our research on capturing CO2 emission in C engines. Now, if you see this proportion of greenhouse gases, various greenhouse gases I told, like carbon dioxide, that is released by combustion of fossil fuel, carbon dioxide that is released due to human activities like organic decomposition and deforestation, then methane, nitrous oxide, carbon dioxide from other activities like agricultural area and all, you will get some burning of agricultural residues. That will also result in carbon dioxide emission and fluorinated gas. If you see this picture, how much carbon dioxide is released from each and every source. The fossil fuel combustion, it dominates very high, that is up to 58%, followed by carbon dioxide, which is emitted by combustion of, I mean, emitted by organic decomposition and deforestation. Then, of course, other emissions like methane, it accounts for 14%, nitrous oxide accounts for 8%, carbon dioxide from other sources accounts for 3%, and fluorinated gases, it accounts for 1%. So if you see this picture clearly informs us that fossil fuel combustion is a major source for carbon dioxide emission. Whether it may be used in internal combustion engine or external combustion engine. In internal combustion engine, it may be, it may originate from petrol or SI engine, petrol engine or SI engine, or C engine or diesel engine. Now, as I told, the main sources of CO2 emissions. Are you able to see this slide, participants? Are
Yeah,
you able
yes,
to see
sir.
this slide? Main sources of CO2 emissions. This picture, of course, depicts what are the main sources of CO2 emissions. If you see, whatever the fossil fuel consumed by different industries like power plant, fertilizer, cement, steel, and pharmaceutical industries, they all, of course, they consume these fossil fuels, especially crude oil related fuels. It may be petrol, diesel, or natural gas, whatever it may be, and they release certain amount of CO2. In addition to that, the stationary compression ignition engine, for example, genset, that also it is included in this sources of CO2 emissions. Now, if you take combustion, the main phenomena of combustion is that air will be supplied and fuel will be supplied into a combustion device. Air and fuel mixture will be burnt, and of course, you will get different pollutants. Like the main primary products of combustion are that CO2 and water vapor. That is the basic primary product. But in addition to that, you will get, of course, oxides of nitrogen, then oxides of sulfur, and other particulate matter and other emissions. But according to the amount of air supplied into the engine or into the combustion device, the carbon dioxide emitted by the combustion device, that may vary. If the combustion is more complete, then you will get more CO2 emission. If the combustion is, I mean, if the supply of air is less, then you will get more CO emission, carbon monoxide emission. By the way, actually, the carbon dioxide emission, it purely depends on the amount of air supplied, the quality of fuel, and the residence time for combustion, all these things. Now, whatever you get carbon dioxide, of course, that is raised to the atmosphere and it is continuously accumulated in the atmosphere. So, if you see this idea, global warming, normally the this greenhouse gases, of course, they protect us from the direct solar radiation. The greenhouse gases act like you know what you call bedsheet or blanket over the earth surface atmosphere, so that we all keep our surface is kept 1 degree higher than ground temperature. By the way, we feel warm. But if that blanket, greenhouse gas blanket is not there, solar radiation will directly penetrate into the earth, and you will get a severe temperature rise. One way the accumulation of carbon dioxide is advantageous because that blanket is always kept constant. But if it continuously increases accumulation of carbon dioxide, which is the main greenhouse gas for the global warming, then you will feel very hot and it will result in climate change as well. So, in that case, everybody has to focus how to control carbon dioxide emission, which is accumulated. There are many ways you can control. One way is that you can use renewable energy sources, as Professor Chinnapandian told. The other way around is that you can implement methods to capture carbon dioxide which originate from different sources. Why I focus compression ignition engines? Because it has wide applications. Carbon compression ignition engines that can be used in transportation like trucks, buses, heavy duty vehicles, locomotives, ships, and boats, like that. And the C engines are also used in generators and power plants. They are used in industrial machineries like construction industrial machineries. They are also used in construction equipment like bulldozers, excavators, and other heavy machineries. That is also used in agricultural machineries like tractors, farm equipment, like combine harvesters. And also, it can be used in irrigation purpose. Sea engines are also used in mining vehicles, oil and gas industries. Since it has variety of applications and carbon dioxide emitted from sea engines is significant, we are focusing on to capture CO2 in sea engines. Again, if you see the sea engines, as I told earlier, sea engines may be stationary, used in stationary application, and it may be used in automotive application. As I told earlier, automotive application, it's bit difficult to capture CO2 because it's a mobile unit. Automotive vehicles are mobile unit, so you cannot adopt any carbon capture unit in that. But in a stationary sea engine, you can easily adopt carbon capture unit which can capture the CO2 emitted from the engine. Now, if you see this diesel generator, which is one classic example for stationary engine, normally diesel generators they are designed to be durable and rugged, robust, and they are also efficient. By the way, nowadays you can see everywhere in multiplexes, hospitals, large residential areas, in fact, commercial buildings, everywhere you can see these diesel generators which are used as standby power generation units. Because of merits like sturdier, robust construction, low maintenance cost, low noise output, less overall maintenance, they are easily used in such applications. Apart from that, they also have longer lifespan and longevity. It can easily, of course, it can yield efficient fuel consumption and it can offer longer service and maintenance, less maintenance intervals compared to the other power units which are operated by natural gas generators. So that's why we go for diesel generator rather than natural gas generator. Of course, you can use natural gas generator as well, but diesel generators are very prominent. And of course, because of the cost of fuel, diesel, you can easily avail that and you can use it in a diesel generator and you can use it as a standby power generation unit. But the main problem with diesel generator, which is a class of or which is a type of compression ignition engine, there are different pollutants arise from that, like oxides of nitrogen, particulate matter, carbon dioxide, carbon monoxide, benzene, polycyclic aromatic hydrocarbon. These are all originate from compression ignition engines. And because of these pollutants, we have two things. One is that it affects our health, and second one is it impacts our environment as well. So if you see this health risk, oxides of nitrogen, particulate matter, all are dangerous. Carbon monoxide, carbon dioxide, polycyclic aromatic hydrocarbon, normally we call it as pH. All, of course, they affect our health, especially respiratory systems and lungs. On the other hand, this diesel generators pollute huge pollutants, as I told, which contribute to global greenhouse gas emission as well as air pollution. Now, if you don't cut down the carbon dioxide emission from these diesel generators, then we may not reduce the overall CO2 emissions released to the atmosphere. Because, as I told, in the modern world, these diesel generators are everywhere used. So, if you see this diesel generators, as I told, nowadays we use diesel generators everywhere. 20 years before, 30 years before, and all petrol generators were used. because smaller applications. But now everywhere you can see this diesel generators because of their efficiency and durability. Some applications of diesel generators are the following. They can be used as standby power plant. They can be used for in commercial operations. They are used in commercial real estate application, industrial real estate applications, property management. They are also used in medical industry, construction project, mining operations, oil and gas operations, manufacturing facility, processing plants, data center, telecom towers. Of course, everyone could have seen the use of diesel generator in telecom tower. That is one classic example. Now, if you see this diesel generators, as on now, diesel generators are available in different ranges, right from small home units that you can see from 5 to 10 kilowatt to large industrial generators with a capacity of 2000 kilowatts or 2500 kVA. That is available for business purpose, and home purpose you can see the power capacity, it varies from 10 kilowatts to 100 kilowatts. Again, that depends on power need. Even you can see small power portable generators that is available in, of course, different countries, that ranges between 2 to 5 kilowatt. And of course, as I told, large industrial generators that can have the capacity up to 3000 kilowatt electrical energy. Now, if you see this generator, diesel generator, we have mainly three types. One is called the portable generator, second one is inverter generator, and the third one is standby generator. Portable generators, of course, you can see everywhere in small places, or you can see in shops like mechanic sheds, stores, car and bike showrooms, hotels. Everywhere you can see that small type or portable type of generators you can carry anywhere as you like. And of course, they can be used to power a small house as well, which can include television, air conditioner, computer, refrigerator. Suppose I have a house, a double bedded house, then I can install this kind of diesel generator, portable generator. It can operate for 18 hours continuously. Then second one is inverter generator. Nowadays, of course, people big houses they install this inverter generator, which can give electrical input to the entire house. So only thing you need is that you need an inverter which can convert DC to AC, which is applied to your house. So this kind of inverter generator they are mainly used in shops like hotel stores, building big commercial buildings. Everywhere you can see this inverter generator. Then you have standby generator. Standby generator, you can see this standby generator capacity available from 250 kVA to 2500 kVA. Like for example, you have construction industry or you have a big manufacturing unit where you can have you can have this kind of standby generator. For example, you have institutional building or data center or of course telecom tower. There you can install this kind of a huge standby power generator. Whatever the type of generator you use, no problem. But the CO2 emission which is released from those generators are significant. Now, after the attraction of this diesel generator, everywhere people started installing this generator. As a result, it become a big headache to government of India. So government of India, of course, formed a commission for air quality management. Normally we call it as CAQM. So they, of course, they brought guidelines for diesel generators alone. So they gave guidelines for different capacities of diesel generators. For example, if you see this diesel generator which is below 19 kilowatt, then you need not to have any system to be adapted to control these pollutants. So no restrictions other than under GRAP. GRAP means Graded Response Action Plan. If the power capacity varies from 19 to 125 kilowatt, then the diesel generator wherever you install, that should run on dual fuel mode. That means initially the engine will run on either diesel or diesel like fuel, and then the engine will set to run on natural gas or any other gas like biogas. But here also there is no restriction other than under GRAP. Then if the power capacity varies from 125 to 800 kilowatt, then the engine has to run on dual fuel mode. At the same time, you should have emission control device, that is called ECD, that should be retrofitted. But there is no restriction even during GRAP, that is a Graded Response Action Plan. That time you don't require to adopt anymore. Then if you have power capacity, power output of diesel generator above 800 kilowatt, then it is necessary to run the diesel generator with the dual fuel mode, or you can adopt any other emission control device. Here also there is no restriction other than under GRAP. So this kind of guidelines were implemented since year 2023. So whatever the diesel generator you buy for your application after 2000 manufactured after 2023, you have to necessarily follow this guidelines which are given by Commission for Air Quality Management. Now, this is one small idea about the diesel generators, what you can use in current day practice. From that, how we can capture carbon dioxide. That is our main focus. Actually, last 10 to 20 years, a term called CCUS or CCS. CCUS means carbon capture, utilization and storage, or CCS, that means carbon capture and storage. These two terms were prominently seen in the research area, especially people who are working in this area. For example, mechanical engineer, chemical engineer, electrical engineer, of course, environmental engineer, all they enter into this emerging area called CCUS or CCS. As I told, because it has a very significant impact on the environment. So, carbon capture, utilization, and storage is one of the emerging areas in research worldwide. Now, what is carbon capture utilization? Actually, if you take a power plant, it may be a coal-fired power plant or diesel power plant, or of course any other natural gas power plant, whatever it may be. We are supplying air or oxygen, fuel, that may be fossil fuel or biomass. So air fuel mixture is burnt in a power plant, that gives different uh, products, that may give different products, mainly primarily electricity. In addition to that, of course, you may get in industrial process, you may get chemicals or fuels. And the main pollutant which comes out of this power plant or industrial process is that CO2. Now, this CO2, first it has to be separated from a main stream of gases which are coming out from the power plant or industrial process. First, it has to be separated, and then it has to be captured by proper material or device. Then the CO2 has to be transported, and then again it can be stored in different places, whether it may be underground or it may be in sea. Different methods are there to store CO2, which is separated and captured. So CO2 can be transported by pipeline or tanker, and then storing can be in different ways that I'll come to that later. Now, CO2 separation and capture, that can be given in three terms called post combustion carbon capture, That is first one. Second one is pre-combustion carbon capture. That is second one. And the third one is oxy-fuel combustion carbon capture. Now, as I told, you have three categories of carbon capture method. Now, all these three types or categories are given in one single plot or single page. Are you able to see slide number 16?
Yes, sir.
Yes,
Yes,
sir.
Yes,
sir.
sir. Yes, sir. Yes, sir.
Okay. So the first one is post combustion carbon capture, the topmost one. Second one is pre combustion carbon capture, and the bottommost one is oxy-fuel combustion carbon capture. So in post combustion carbon capture, what is the philosophy or the basic idea is that you will separate the CO2 from the flue gas which is coming out of a combustion device, that is CO2 which accounts about 3 to 20 percentage in the flue gas. First you have to separate the CO2 and then you have to capture that CO2 and then transport and store. So here after separation of CO2 from the main stream of flue gas, you will get CO2 removed flue gas that you can send it to the atmosphere. So post combustion means after combustion, like in automotive vehicles, what you have like exhaust gas after treatment or exhaust control devices are the same like that. Here post combustion, after combustion you can control CO2 by separating and capturing. The second one is pre combustion carbon capture means you will have a gasification and a partial oxidation process. Actually, fuel is supplied separately. Air, of course, which has 21% of oxygen and 79% of nitrogen. First, you will use an air separation unit. In the air separation unit, nitrogen will be removed. Only you will have oxygen that will be supplied to your gasification partial oxidation process, and then it will be given for reforming and CO2 separation. So once CO2 separated, then you will get H2 as a fuel that will be given for power and heat, power production or heat energy production or heat production. So whatever the gases which are coming out, that may be, of course, water vapor, N2, O2, all these things. CO2 which is separated after reforming, that will be stored separately. That will be stored separately. And the bottommost one is called oxy-fuel combustion carbon capture. In oxy-fuel combustion capture, here like a pre-combustion carbon capture, here also you will use an air separation unit. So pure oxygen you will supply. By the way, of course, you will allow oxygen into the combustion device, so you will get, of course, neat combustion process. Here you will get more complete combustion. So CO2 and water vapor are the main products you will get. CO2 will be separated and stored. So the first one, post combustion carbon capture, that is easier because that can be integrated. Post combustion carbon capture device can be integrated after heat engine. It may be power plant or it may be a diesel generator, whatever it may be. At the exhaust after the engine, you can keep this post combustion carbon capture unit. But if you take this pre combustion carbon capture, you have to install the unit before combustion process. Same oxy-fuel combustion also, you have to install this device before the combustion process. By the way, many people are working on this post combustion carbon capture because it is easy to implement. Now, as I told, if you want to capture carbon dioxide, first you have to separate carbon dioxide from the mainstream of the gases. Then, of course, carbon dioxide can be captured. So different techniques are used for carbon dioxide capture. Normally we call it as carbon capture. So depending on the phenomena, you have five methods. One is called absorption, carbon dioxide capture by absorption, AB. Second one is carbon dioxide capture by adsorption, ADSORPTION, adsorption. Third one is membrane carbon capture by membrane. Then fourth one is cryogenic carbon capture, and the fifth one is hybrid. Now, if you see this, the first one, absorption process, again it has two types. One is physical absorption, second one is chemical absorption. Adsorption, again it's like a previous one. You have physical absorption, second one is chemical absorption. And the third one, membrane, in membrane carbon capture, normally we have two types. One is using polymeric or organic membranes for carbon capture. Second one is using inorganic membranes. In inorganic membranes, you have two types. One is porous inorganic membrane that can be used. Second one is non-porous inorganic membrane that can be used. So this membrane separation, membrane carbon capture, it's very much used in chemical industries, especially if you see this steel, then cement, everywhere you can use it. Membrane separation process that is used. So people who are working in these industries, they know very much about this membrane separation process. So if you just see this, if you see this absorption process, I skip that. I don't want to elaborate more. If you see this absorption, there are different advantages of this absorption process. It is simple and energy efficient, economical, eco-friendly process. You can get maximum CO2 capture efficiency with this absorption process. Minimum energy consumption for regeneration means you can use that material adsorbent, normally called adsorbent, that can be used again and again. That's called regeneration. It is non-corrosive to adsorption and desorption chamber. It can be used in a wide range of temperature and pressure. So if you see this adsorption process, how adsorption can be used. Actually, normally we use activated carbon as adsorbent. So this adsorbent can absorb the carbon dioxide which is available in the gas. So it is a surface phenomena. As I told you, you have two methods. One is physical absorption, second one is chemical absorption. Where in physical absorption, van der Waals force of attraction and electrostatic force of interaction that take place, while chemical absorption, chemical bond interaction between absorbate and adsorbent that take place. If you see this applications of adsorption, as I told, you can use it for greenhouse gas adsorption. It can be used in air pollution control device. You can use it for carbon dioxide capture. It can be used in a hydrogen storage device. It can be used for electrical energy application. It can also be used in ultra supercapacitor. You can use it for wastewater treatment. Some people who are working in environmental engineering, they use activated carbon for wastewater treatment like that. You can also use it to remove heavy metals like arsenic, chromium, and all. You can also use it to remove pharmaceutical substances from sewage effluent. Now, if you see this activated carbon, in water filters also activated carbon is there, right? Normally, this activated carbon is obtained from biochar generally. So, biomass is a main substance to produce activated carbon via biochar. Why we should use this biomass? Because it is abundantly available. It is inexpensive raw material. It can give very good CO2 absorption capacity. It has very good kinetics mechanism, high resistance to moisture. It offers good thermal and mechanical stability. It has very good CO2 selectivity from the mixture of gas constituents. Whatever the gas constituents, it may be from chemical industry or it may be from oil refinery, whatever it may be. It is able to withstand multiple absorption and desorption cycles. So that's why we focus on this absorption. Now, why we use this, uh, why we focused on CO2 capture in diesel generator. We went through different various literatures available on carbon dioxide capture in different composition devices using all these four methods: absorption, adsorption, membrane, cryogenic. All we went through, and finally we chose this. What are the research gaps followed? What are the research gaps? What we found? Then we collected based on the based on the literature review, we found some of the important research gaps. Of course, everyone is working on membrane separation. Large number of people are working on membrane separation because it's commonly available. But if you see this absorption, cryogenic, less people are working. So even in that, only a limited number of research works that were carried out in capturing CO2 in diesel generators or diesel engines using adsorbents. So that is one of the key points why I insist that you can carry out research in this direction. One is diesel generators are coming up. It's an emerging device wherever you can see diesel generators are available. Second one is that CO2 emission, control of CO2 emission is also an emerging research area. So we combined these two and we did some research works in this area. So we chose some biomass materials that were converted to, of course, converted as adsorbent, then used as raw material for capturing CO2 in a diesel generator. Why we chose biomass? Because this biomass actually activated carbon that you can obtain from biomass, and this biomass based activated carbon, it acts as a good adsorbent for CO2 capture. And of course, the post combustion means you can integrate your device after engine exhaust, and you can adapt absorption technique easily. That's why we focused on post combustion carbon dioxide capture via adsorption, using adsorption technique in a diesel generator. So that is our main research work, what we did in the last 6 years, of course, that I would like to present it here. Some of the important areas I would like to present here, so that anybody is interested to work in this area, you can enter into this. So here in our research, what we did, we chose some biomass materials, converted into activated carbon, and then using that activated carbon, we captured CO2 from a diesel generator exhaust. So principally we chose three different commonly available feedstock. One is called coconut shell, second one is rice husk, third one is eucalyptus wood. So these three materials you can see anywhere in India. So that's why we chose this as a potential feedstock to get activated carbon. So if you see this coconut shell, rice husk, eucalyptus wood, their important parameters are given in this table, like chemical composition, family name, botanical name, growing condition means how they grow, how much where they are available, and what kind of preparation method you can follow to get activated carbon from these materials. All are given in the table. For instance, if you take coconut shell, the chemical composition is given in cellulose, hemicellulose, lignin, and other contents. Cellulose accounts for 41 percentage, hemicellulose accounts for 26 percentage, lignin accounts for 17 percentage, and the remaining goes to 14 percentage. Rice husk, it is in the same range. Like cellulose, it has 38 percentage, hemicellulose 27 percentage, lignin 19 percentage, and the others accounts for 16 percentage. Eucalyptus wood is also having cellulose 40 percentage, hemicellulose 30 percentage, lignin 15%, others accounts for 12 percentage. Because of the similarities, we chose this coconut shell, rice husk, and eucalyptus wood as our feedstock material. That is also one of the reasons we chose this. and of course family name and botanical name you can see, growing conditions you can see, everywhere you can get this coconut tree, rices, of course in tropical region you can see, eucalyptus also you can see in tropical regions. Preparation, how we can prepare this activated carbon, that is given. Coconut shell you can get it through thermochemical conversion process, normally pyrolysis, a process called pyrolysis. With that help, with using that you can get this activated carbon from coconut shell. Rices and eucalyptus wood, they also can be obtained using thermochemical conversion process, generally pyrolysis. Some people have explored to produce activated carbon using gasification also, but those literature are very less available, very less. Now, what are the steps involved in preparing this activated carbon? For carbon dioxide capture, you need an adsorbent, because here we are focusing on adsorption method. But some people used absorption, some people used cryogenic capture like that. But we focused on adsorption process, in which of course we used activated carbon that was obtained from these three principal feedstock like coconut shell, rice husk, and eucalyptus wood. So how to prepare this activated carbon? So here there is an illustration given. Are you able to see figure 10 steps involved in activated carbon preparation? Slide number 24.
Yes, sir.
Yes, sir. Yes, sir. Yes, sir.
Okay. So the top one is steps involved in sample preparation. First of all, you have to prepare this feedstock, means whether you take coconut shell or rice husk or eucalyptus wood, any biomass you can take, but it should contain cellulose, hemicellulose, and lignin in a major proportion. So you can take any biomass material and that you consider as a feedstock. First, you have to remove moisture from that. That is the first step. Then you have to remove dust, dirt, foreign particles. After drying the feedstock, after removing the moisture, you have to remove dust, dirt, foreign particles. Then you have to subject the feedstock to carbonization process. What is carbonization? First, you have to undergo pyrolysis process, where you will get a solid product called biochar in a pyrolysis process. If you don't have any idea in pyrolysis, you can just read that. So with the pyrolysis is a thermal decomposition process. So in a thermal decomposition of this feedstock, you will get the three principal products. Namely, if you use biomass material, you will get three principal products, namely bio oil, biochar, and synthetic gas or syngas. So you take only biochar, which is obtained normally pyrolysis process. You get biochar as a residue at the bottom of the reactor. That biochar will be carbonized at a temperature of 800 degrees Celsius. Then you add some chemical agent. Normally we use uh, potassium hydroxide and add chemical agent and heat the mixture at 550 degrees Celsius. Then you will get, that process is called activation. So once you get that, of course, you will prepare this biomass based adsorption for absorption. As I told here, activation, you can normally after carbonization you are doing chemical activation. What is chemical activation? Adding chemical agent like potassium oxide. After that you will get the activated carbon. First you will get biochar, then you will get activated carbon. Then that activated carbon can be weighed. How much activated carbon you obtained from this entire process, that you can weigh, and then you can allow it as an adsorbent for capturing, separating and capturing CO2. So this is a picture, group of pictures which show coconut shell sample, rice husk sample, eucalyptus sample. So after converting this feedstock materials to activated carbon. How this activated carbon looks like, it is shown below this, uh, below bottom row. Top row it shows pictorial pictures of the three materials, raw materials. Bottom row it shows the activated carbon obtained from coconut shell, rice husk, and eucalyptus wood. Again, as I told, the quality of feedstock what you use, based on that you will get activated carbon. Whatever the method you follow, final product activated carbon, it will give different, I mean, different nature or different characteristics of them. So if you just look at this bottom row picture, coconut shell activated carbon, it looks like a bit larger compared to the activated carbon what you get it from rice husk. If you see the last picture, eucalyptus wood activated carbon, the size is still larger. So characterization of these materials, activated carbons, is very very important before you use them as adsorbent for CO2 capture. So we characterized, of course, this activated carbon samples which are obtained from coconut shell, then rice husk and eucalyptus wood. So whatever the sample you take for characterization, first you have to uh, do proximate analysis and ultimate analysis. What is proximate analysis? A proximate analysis will give you an idea of how much fixed carbon, volatile matter, moisture content, ash content are present in your substance, in your activated carbon. That is called proximate analysis. Ultimate analysis, it gives in-depth idea of the percentage of carbon, hydrogen, nitrogen, oxygen, and others present in, normally sulfur, of course, sulfur or other compounds which are present in the substance. Here we take activated carbon. So the proximate analysis and ultimate analysis of activated carbon obtained from these three samples were done for coconut for coconut shell activated carbon, rice as activated carbon, and eucalyptus wood activated carbon. So the results of them are given in this table. So if you see this, the amount of fixed carbon available in the activated carbon is very very important. If you just look at it, coconut shell activated carbon, rice activated carbon, eucalyptus wood activated carbon, they are above fixed carbon, that is above 80 percentage. That's a good sign. And volatile matter, it is in the range of 9 to 8 to 10 percentage. So if you see this ash content also, ash and moisture content also very important. That's very less. Now when you see this ultimate analysis, here also you can see the percentage of carbon available in that for activated carbon. It ranges from 79 to 83 for these three different samples. So one has to, of course, understand how suppose activated carbon is used to capture the CO2. There are two terms. One is absorption and desorption. It will capture and release. So in that way, the absorption and desorption characteristics were studied for these three samples, like coconut shell activated carbon, rice husk activated carbon, and eucalyptus wood activated carbon. So N2, how much nitrogen absorbed, that is given with respect to relative pressure. So here if you see this eucalyptus wood activated carbon, that shows very high for both absorption and desorption. Rice husk, it shows very low absorption and desorption curves. Similarly, if you see this uh, activated carbon, which was obtained from three different samples. Actually, pores are there in the activated carbon. So those pore size and pore volume, they play very, very important role in capturing CO2. So pore volume was studied with respect to pore width for these three samples: coconut shell activated carbon, rices activated carbon, and eucalyptus wood activated carbon. So with respect to pore width, what is the pore volume? That is just measured and plotted. Now, if you see this activated carbon, their surface textural characteristics that were also studied. Means BET surface area, that is one of the important characteristics. Micropore surface area, external surface area, micropore volume, mesopore volume, total pore volume, average pore diameter. All these things were studied for all this activated carbon, which we took for our studies. In addition to that, of course, the SEM image, scanning electron microscope images were captured used for these three samples. That means before and after. Actually, before activation, that means after carbonization, before activation means carbonization. Carbonized, carbonized coconut shell, carbonized rice husk, and carbonized eucalyptus wood. They were studied. Then after activator, after preparation of activated carbon, how they look like, that is also shown here. Using SEM, we got these images and we measured the pore volume, pore size, all these things. So, in addition to that, the thermal stability of the activated carbon samples were also studied for these three samples. So, weight loss, if you just increase the temperature of the substance, how weight reduced for each and every substance, each and every activated carbon, that was studied. So, this picture, it shows weight loss versus temperature uh, for these three samples. So, if you see these characteristics of this activated carbon, characterization of this activated carbon, you can see these samples, all these three samples possess a large surface area, specific surface area, okay, that showed a very good sign to capture CO2. The high pore volume, about 0.98, 0.75, 1.59 centimeter cube per gram for these substances, these adsorbents, of course, again showed a very good sign for capturing CO2. Because of this, of course, we can take these samples, you can use it anywhere, no issues. Activated carbon samples, of course, they exhibited better surface morphological texture and excellent absorb, absorptive pore sites on their surface. That means when this activated carbon, they were exposed to carbon dioxide present in a combustible gas or exhaust gas of an engine, it can easily capture, absorb. And of course, they also have sufficient surface functional groups. As a result, it can capture maximum amount of CO2 from the steam. And they also have high thermal stability. So we can use this activated carbon even at a very high temperature. For example, if you take exhaust gas temperature of a diesel generator, it may go up to 400 degrees Celsius. If you take a single cylinder diesel engine, the exhaust gas temperature is about 200 or 250 degrees Celsius. Whereas if you take a diesel generator, it may go to 400 degrees Celsius. Again, it is up to the capacity of the generator. So in that case, this activated carbon can be used without any hesitation. You can use it as an absorbent in a diesel engine exhaust. So So this is an idea of characterizing this activated carbon. Now, after the characterization, we fabricated two things. One is a water cooled heat exchanger, and the second one is we also fabricated an absorption chamber. Why water cooled heat exchanger is required? Because the gases have to be first cooled, then it can be absorbed. CO2 can be absorbed. Only for that, we actually the gases which is coming out, which are coming out from the engine exhaust, as I told, it is about 200 or 250 degrees Celsius. So we wanted to first reduce the temperature of the exhaust gas to certain temperature. Then we used to we capture this CO2. For that, we fabricated a water cooled heat exchanger. Then that cooled gas that was allowed to a device called absorption chamber. So here this picture shows a water cooled heat exchanger, I mean schematic diagram. On the right hand side it shows the picture photograph. Same like that bottom you can see the schematic diagram of absorption chamber is shown, and right hand side the photograph of the absorption chamber is shown. So once we fabricated all these things, we wanted to conduct a series of experiments using this activated carbon, which is filled in the absorption chamber that was combined to a diesel engine exhaust. Initially, we did not make attempt directly attaching it to a diesel generator, heavy diesel, big diesel generator. Rather, we first conducted series of experiment by attaching this uh, absorption chamber with a single cylinder diesel engine. So we measured the different parameters, including emissions, and then we plotted different graphs. So in that sense, this picture it shows schematic layout of an engine setup with the post combustion absorption chamber that is combined. So we fabricated two devices. One is water cooled heat exchanger. One we fabricated a water cooled heat exchanger. The schematic is shown in the left hand side, and the photograph is shown in the right hand side. Second one, we also fabricated an absorption chamber, which is shown below. Schematic diagram is shown below, and the photograph is shown at the right hand side. So we, after fabricating these two devices, we combined this water cooled heat exchanger and this absorption chamber at the engine exhaust of a single cylinder air cooled diesel engine. We measured the different parameters. So first engine, after that water cooled heat exchanger, which was able to reduce the temperature of exhaust gas. Then that exhaust gas was allowed to an adoption chamber. So now is it visible technical specifications?
Yes, sir. Visible, sir.
Yeah. So as usual, what we use at single cylinder air cooled engine that we used, the technical specifications are given. So this is the photograph of the setup. So there you can see engine test bed is there. After that, we had the water cooled engine and the absorption chamber. So that part number 13 is the absorption chamber. So of course, we also studied before we conducted the experiments. We also studied the absorption capacity of each and every material activated carbon at 20 Celsius, 75 as different as well. What is their absorption capacity in millimoles per gram that we measured and we plotted here. So then, of course, we conducted the experiment with, of course, diesel. 100%. We ran the diesel engine with 100% diesel with and without absorbent. So adsorbent was packed at different mass basis, at different mass, like 2.5 kg, 5 kg, like that. 1.25, 2.5, 3.75, 5, and 6.25 kg of activated carbon was filled in that activation adsorption chamber, and then we ran the engine at different loads with diesel as a fuel. So we measured the carbon monoxide, carbon dioxide, unburnt hydrocarbon, oxides of nitrogen, all we measured. So their plots are given. Of course, this is the CO emission with respect to load at different loads. When we used coconut shell absorbent, rice absorbent, and eucalyptus wood absorbent as material. Then this is CO2 emission with respect to load for three different absorbents used at a different, of course, packing. That means 1.25 kg actuation. That absorption chamber was packed with 1.25 kg, 2.5 kg, 3.75 kg, 5 kg, and 6.25 kg of activated carbon was filled in that absorption chamber, and then that was connected to engine exhaust. Then we measured this emission, CO2 emission. This is same kind, but HC emission was measured at different loads. Then this is NOx emission measured at different loads for the same kind of test. So then from the results, we concluded something which are given here. The maximum absorption capacity of 5.65 millimole per gram, 4.95 millimole per gram, and 6.35 millimole per gram is attained for coconut shell, rice husk, and eucalyptus activated carbon at 2.5 bar pressure and 25 degrees Celsius. That means ambient temperature itself we can operate, but slightly with a high pressure, if you work, you will get maximum absorption capacity. And CO and CO2 reductions were significant, up to 20% and 44% for all these materials when used. HC emission also that was drastically reduced. That means since of course there is a slight difference is that there was a slight back pressure. Of course, again when you increase the packing, that HC was found a little more compared to less packing, and the NOx reduction was also significant that ranged between 22% to 39% when used these three different activated carbons. Now, same kind of materials we took and used in, of course, diesel generator. Earlier we used only in a single cylinder diesel engine. The same kind of setup was installed in a diesel generator. So this is a pictorial schematic diagram of the entire engine setup, diesel generator setup, which included this post combustion single absorption chamber. Initially we tried with the single absorption chamber, then we also conducted with the double absorption chamber. Then we measured all these parameters like HCCO, CO2, NOx emission, all we measured in addition to fuel consumption. So here, of course, we chose a diesel generator, the capacity of about 62.5 kVA. The power output of a diesel generator, that was 62.5 kVA. So that was chosen and that was used. So here, this is a photographic view of a diesel generator which we used for measuring the CO2 emissions after capturing the CO2 in the exhaust of the generator using this absorption chamber. Are you able to see this photograph? Audience, please.
Yes, sir. Yes, sir.
So this is a diesel generator, and of course we installed a water-cooled heat exchanger and the absorption chamber. So same kind of experiments we conducted with the three activated carbon, and we measured CO, CO2, HC, and NOx emission. First, as I told, we conducted with single absorption chamber. Then we conducted with double absorption chamber at the engine exhaust. I mean diesel generator exhaust. So here same kind of setup is shown with a double absorption chamber. And here also we measured HCCO, NOx and CO2. Summary alone I am just showing because of the time constraint. So here if you see that eucalyptus wood based absorbent, it was able to capture more amount of CO2 than coconut shell and rice husk activated carbons. And you can get a simultaneous reduction of CO2 and NOx up to 65% and 54% respectively when we use that eucalyptus wood absorbent as an eucalyptus wood activated carbon as absorbent, which was filled in a double absorption chamber that was coupled to a diesel generator. Again, if you see that when you used a double absorption chamber, that was able to cut down CO2 emission by maximum of 60% for all the three absorbents compared to single absorption chamber. That means about 60%, 16% improvement was there. Same kind of improvement was noticed in NOx emission also. NOx was reduced by about 30 to 40%, which was 16% more than single absorption chamber. So what is suggested that you can use a double absorption chamber as well if you have very good facility and there is a less back pressure. And of course, we also studied the absorption parameters of the absorbent chamber, absorbent samples, what we studied, like coconut shell absorbent, that is the coconut shell activated carbon, eucalyptus activated carbon, rice husk activated carbon. All these samples were studied for their absorption capacities or absorption parameters. So here this slide shows the absorption capacity for three different samples taken and they were subject to different moisture content varying from 0% to 60%. When the moisture content of this activated carbon increased from 0 to 60%, how the absorption capacity varied or reduced. That is shown in this picture. If you see that the eucalyptus wood absorbent, it has a very high absorption capacity of about 6.25 to 6.3 millim, 6.25 to of course 5.9 something around millimoles per gram of absorption capacity was there in that case, and that is followed by the coconut shell absorbent, and finally of course you have rice husk absorbent. Then we also studied a fractional uptake with the absorption time duration. That means how long you can use it, this activated carbon. That is shown. So this picture, it shows the variation of frictional uptake with absorption time, that is shown in minutes. So here also a similar pattern is shown for all these three absorbents. Then of course breakthrough profile of adsorbents, adsorbent samples are given. Coefficient is shown. Then of course isosteric heat of adsorption with different absorbents or absorbents, that is studied. As I told, we took that activated carbon and filled in different quantities like from 1.25 to 3.75. So when you vary this, how much isosteric heat of absorption is there, that was studied in this three cases, for these three cases. And of course, when you use this activated carbon in absorption chamber, which was connected to the engine exhaust, as I told, there will be a back pressure. If you pack more and more activated carbon, then what will happen? There is a chance of back pressure applied to the engine. So in that case, fuel consumption will increase. So that is depicted in this picture. How this fuel consumption trend is there when you use this activated carbon in the engine exhaust. You see this plot. It is depicted for fuel consumption at different loads. When you apply these three activated carbons, coconut shell, rices, and eucalyptus wood activated carbon. So all these three, they show similar kind of patterns, but they are very closer curves. Then a pressure drop, as I told, when you pack this activated carbon in an absorption chamber and connect it to an engine exhaust, obviously when you increase the load and increase the packing of this activated carbon, there will be a pressure drop in the engine exhaust. So as the load is increased, pressure drop increased. The pressure drops down from 2.5 to, let's say, 2.2 or more like that. So here you can see eucalyptus wood activated carbon that exhibited high pressure drop, whereas the rice as kit showed less pressure drop. So as a summary, with the 50 percentage of moisturized absorbent, the maximum absorption capacity is reduced by 9.8 percentage, 10.2 percent, and 9.1 percentage for coconut shell, rices, and eucalyptus wood activated carbon respectively, compared to 1 percentage moisture present in the activated carbon. Then all absorbent samples needed only 15 minutes to absorb nearly 85 to 90 percentage of the adsorbate molecules. That means the CO2 that entered into the absorption chamber. And of course, the eucalyptus wood and the coconut shell absorbent samples consume more fuel consumption than the rest one. Pressure drop for eucalyptus wood and coconut shell absorbent samples is a bit higher than the rice sample. And of course, we also studied the regeneration characteristics of the adsorbent samples we took for the study. What is regeneration? Of course, once I pack this activated carbon, I use it for some time. Again, that activated sample is cleaned and means CO2, whatever CO2 absorbed by that activated sample, that will be removed, and then again I can use it. That's called regeneration. So that kind of regeneration study also we studied, and absorption isotherm models also we studied. So this picture, it shows the variation between absorption capacity and number of cycles. We ran the engine continuously for say 1 hour, 2 hour like that, and uh, suppose you run the engine from no load to full load, that we call it as one cycle. So like that we carried out different cycles varying from 4 to 48 like that. So what is the absorption capacity of these three activated carbons that were studied and then plotted here? So all they show similar kind of pattern when you use this activated carbon in the absorption chamber. Then absorption and desorption cycle curves of these three activated carbons are shown here. Absorption means what? It will absorb the carbon dioxide, and desorb means it will be uh, released. So in that case, all they show similar patterns when we conducted at different cycles that carried out for about 2500 seconds. So this plot, it shows for these three samples. That means coconut shell, rices, and eucalyptus wood activated carbons when they are subjected to this absorption and desorption cycle study. So chromatograms for spectroscopics for gas components. Of course, how much gas was absorbed means when an exhaust gas is coming out of an engine, it consists of mixture of hydrocarbon emission, hydrocarbon, carbon monoxide, carbon dioxide, nitric oxide, oxides of nitrogen, and O2, everything. So each and every gas, how much it was captured over a time period that is shown in this three plots for each and every adsorbent. And absorption isotherm models that I skip, this also we can study. As a whole, we can give a summary. All adsorbent samples exhibit where regeneration perform. That means you can use them and again. Use those absorbents like activated carbons. You can use them again and again. It will not end up. So you can run for 2 hours, 3 hours. Suppose you run a diesel generator for 2 hours continuously. You can continuously you can use this activated carbon. Of course, without any time period. You can run that diesel generator. Suppose you run that diesel generator for a year. I mean, for a year or 6 months. Without removing this activated carbon, you can use it. Or if you want to have a higher efficiency, then you have to regenerate and then you have to pack. Again, you have to pack it and you can use it. So, all adsorbent samples show maximum CO2 and NO capture or NO peaks, which ensures maximum CO2 absorption performance. So, again, if you see the overall conclusion of the entire study, of course, surface area of these three activated carbons, they are in the range of 1530 meter square per gram to 2500 meter square per gram. And pore volume is also very much prominent, so that you can use them as activated carbon for absorption. And the maximum absorption capacity is about 5.6, 4.9 and 6.3 millimole per gram was recorded for three different activated carbon samples, namely coconut shell, rhizus and eucalyptus wood activated carbon, which was measured at 2.5 bar and ambient temperature of 25 degrees Celsius. And you can achieve a simultaneous reduction of carbon dioxide and NOx at a percentage of 52 and 42 percentage respectively for the coconut shell, and for rice you can achieve 40 and 30 percentage respectively CO2 and NOx 40 and 30 percentage reduction, and you can achieve 65 percentage and 54 percentage of reduction of CO2 and NOx when you use eucalyptus wood activated carbon. All these three, when you use it in a double absorption chamber that was coupled to a diesel generator. So, maximum CO2 you can achieve with all these three samples. Of course, these are all some of the ideas or results what we got from our research study. And we can extend this carbon capture system to any direction. That means you can boost the system or improve the efficiency by incorporating the absorption chamber anywhere, of course, to any genset. And of course, you can also use hybrid method that can be adapted to minimize energy consumption and maximize carbon capture efficiency. Hybrid method means absorption. That kind of method you can adapt. And of course, you can again extend the study by exploring different biomass based absorbent or synthetic based absorbent that you can take it. You can explore different catalytic material also that can be doped in this absorbent to improve the capturing efficiency. That means carbon dioxide capturing efficiency. So with this, of course, I thank all the participants to patiently listen my lecture. Thank you very much. These are the some of the references what you have. Thank you.
Participants, any questions I can ask now? Participants?
Good afternoon, Professor Murugan sir. I think this elaborate.
You can introduce yourself and then.
Yeah, I am Dr.
Introduce yourself.
Yeah, I am Dr. Purusothaman. I think we are attended the two YOC datas today. We observed all the the conversion of CO2 into other residual gases. The exhaust gases. So only one doubt I have. If you introducing some obstacle in the post combustion chamber, what is the? I think you are showing the pressure drop also is there.
Back pressure will be there.
Yeah, back pressure. Due to the back pressure, have you observed any efficiency changes in the combustions?
No, we measured fuel consumption. That is the reflection of efficiency, no?
Yeah, obviously efficiency will be reduced, right? It will increase the fuel
Yeah.
consumption, right?
Everybody will talk about fuel consumption, of course, not efficiency.
Yeah.
So I have shown a graph for fuel consumption.
Okay.
So if back pressure increases, fuel consumption obviously will increase.
Okay, right. Thank you very much.
Thank you.
Professor, there is one question from chat box. Is activated carbon enough to
Chat
effectively
box,
reduce CO2?
I don't know how to use the chat box. Just a minute.
I will read out questions.
I'm unable to see.
I will read out, Professor. I will read out the
yes,
questions. Is activated carbon enough to effectively reduce CO2, HEC, CO and NOx emission, or only CO2? This is a question from
Yeah, it's a very good question.
Jay Kumar.
We mainly focused. Actually, activated carbon helps to capture CO2. That is the main function.
Okay.
We also measured how the engine exhibited its emission in terms of unburnt hydrocarbon, carbon monoxide, oxides of nitrogen. Any activated carbon will, of course, first capture CO2. That is its characteristics.
Okay. So, another question from.
If more CO2. Yeah, please.
Another question from Mr. Ilangovan Ramasupu. Once the CO2 is captured in the activated carbon, how is that CO2 is disposed? Is that CO2 safely disposed and not allowed into atmosphere? Once again, once the CO2 is captured in the activated carbon.
Again, it's a very good question. Actually, cleaning is done. That is one way. Since it's experimental work, we removed that CO2 from the absorption chamber. Actually, activated carbon is there, no? Activate after capturing the CO2 by activated carbon. Weight will increase. Slight weight increase will be there. That is the indication. So that activated carbon is a biomass material obtained from biomass. That we didn't do. Actually, removal of CO2 from that. Actually, we used some chemicals to remove that CO2. That I forgot that name. What kind of chemical my research scholar used. So then again we filled. Regenerate. It is not a regenerate.
Is there any life cycle for this absorbent, sir? How many hours you can use the same?
I showed that number of hours now 2500 second at the time we conducted. 2500 by 60 means how much?
Minutes. You are shown in minutes, right?
Yeah. Actually, what we did, you start the engine, run from no load to full load.
Yeah.
Then we stop the engine for some time again because it was a lab level experimentation.
Okay.
Since it was used by many people, we of course safely worked on this experimentation.
Yeah.
So you can run the engine for 2-3 hours continuously, no issues.
Okay.
But after that pressure drop will increase. Of course, the pressure drop will be there.
Okay, right.
So back pressure will be there. I'm sorry, back pressure will be there. So if you don't remove that activated carbon and regenerate, then engine will slow down.
anything. Yes, sir. Yes, sir. Thank you.
Okay, Professor. Another question from Dr. G. Balaji. How to degenerate activated carbon to reuse? How to degenerate activated carbon to reuse? Is a question from Dr. G. Balaji. Professor?
Actually, yeah. Activated carbon, of course, we didn't do that work extensively. Regeneration part, like particulate regeneration, in particulate, there is a term called particulate regeneration. Particulate filter. If you take particulate filter, which is attached to a diesel generator, that absorbs particulate matter and carbon soot. Normally, what they do for regeneration, they remove the particulate matter, particulate trap that is removed and either manually cleaned by burning the carbon soot or continuously apply air, compressed air. If you forcibly send the compressed air, then that carbon soot will fly. One person asked here, of course, just about this, you can see whether that the carbon dioxide again will harm environment. Of course, that's why we store that carbon dioxide and reuse it and we use it for future application. Carbon dioxide can be used in different applications. That is used in industries, mainly carbon dioxide that is used in industries.
Oh. Okay, Professor.
So
Another question.
solid form or gaseous form we can use in industry. That is separate area. Actually, carbon, I told you, carbon capture, utilization and storage. So we focused only on carbon capture, not utilization or storage. You can store this carbon dioxide in different forms. That we didn't focus. Only we focused on to capture CO2 from diesel generator exhaust. That's all.
Okay, Professor. Another question.
That's it. That again, it's a big area. After capturing the CO2 from the engine exhaust, how we can use, how we can regenerate. You can go through that study. You can do that study.
Okay, Professor. Thank you. Another question, Mr. Prabhu C. How do we ensure that carbon obtained is an activated carbon? How do we ensure
Again,
that
it's a very simple answer. No. The main character of activated carbon is that it has very high absorption capacity of carbon dioxide, not other gases, other gas constants like NOx, HC or CO. So, as I told in my presentation, by studies, experimental studies, we understand that carbon dioxide is captured about 80 to 90%. 80 to 90% of carbon dioxide is captured in our study. Remaining, of course, other gas constants may be there, but 80 to 90% carbon dioxide is captured from the engine exhaust. So weight, actually what we do, we weigh the absorption chamber before conducting the experiment. What is the weight of the absorption chamber? After conducting the experiment from no load to full load, what is the weight increase in the absorption chamber? So this difference will give the increase in the amount of carbon dioxide that is captured by the activated carbon. As like catalytic converter can use moving vehicles. Of course, in the first itself I told, if you use this absorption chamber in a moving vehicle like diesel car or truck, lorry, bus, everywhere, capturing carbon dioxide is a bit difficult because gases are continuously coming out and the vehicle is not stationary. So this kind of a carbon capture system is very much effective if you adopt in a stationary engine. That's what we chose diesel generator. So we chose a very low capacity diesel generator, that is 62.5 kVA. you can adopt it in, of course, 250 kVA, 500 kVA, whatever it may be. That is again next study. It may be a next study.
Professor, one question from my side.
Or future
Is it
study.
any
Yeah,
government
please.
policies to reduce CO2 level because Paris Agreement 2015
Obviously,
Paris
you can
Agreement.
visit. You can obviously you can visit Central Pollution Control Board. In Central Pollution Control Board website, how much emissions, that means CO2, not CO2, HC and NO, HCCO, HCNO, and of course particulate matter control, it is given data.
Oh.
CO2, there is no specific rule is given so far, value is given so far in CPC, but it may be updated. You have to check.
So, any other questions from participants? Otherwise, our next
So you can
speaker is
frequently
waiting.
visit. Frequently visit.
So
Next
just one
speaker
question
is
from me,
waiting.
Karthikeyan. One
Okay.
question from me, Karthikeyan here.
Yeah.
Sir, in one of the slides, I think 28 or 29, you have plotted nitrogen versus pressure. I mean relative pressure.
N2 absorption.
N2 absorption. What is that, sir?
Actually, the exhaust gas, no.
Yes, sir.
For example, no. For example,
Yes, sir.
yes, sir. Yes, it contains not only these gases, unburnt hydrocarbon, carbon monoxide, carbon dioxide, oxides of nitrogen, water vapor. It will also carry very less percentage of N2 because we are supplying atmospheric air, which contains not only oxygen, major component is nitrogen. So basically, if you see this combustion equation, if you take combustion equation CmHn plus O2, that gives CO2 plus water vapor. That is the basic combustion equation. But that combustion equation may alter according to how much air you supply, whether you supply stoichiometric air or excess air or less air. Based on that, you can measure oxygen in the exhaust. Suppose more air is supplied, you will get oxygen also in the exhaust, and N2 also you will get. What I remember or recall, he measured that one. One of my research scholars, he measured that. If I'm you have to correct, of course, if you know that. How to handle for different storage system with internal property? I'm unable to get this question, Mr. Tawamani. How do you handle for different storage system? Storage means capture or storage? I don't know what question is asking.
If any other questions, can directly contact our professor. Always will tell the answer because next speaker
Of course,
is waiting.
some slides I would have skipped or I would have picked a different information. Because of time availability, I could not just elaborate it. So thank you for your patiently listening.
Yes, sir.
Thank you, professor. Thank you very much.
Sir. Yes, sir.
Yeah.
Please,
Thank you,
sir.
thank you.
Really enjoyed your session, sir. Really. Now, Dr. Satrar, you can give a vote of thanks.
Yes,
Yes, sir. Thank you. As we conclude this enlightening session of this faculty.
Should I switch on the camera?
Yeah.
Yes, sir.
Yes, sir. Yes, sir.
Okay. So let me conclude. So this enlightening session of this FDP on carbon capture in CI engines environmental effect. First and foremost, I extend my sincere gratitude to our esteemed speaker, Dr. S. Murugan, Professor of Mechanical Engineering at the National Institute of Technology, Rourkela, for sharing his invaluable knowledge and expertise with us today. His outstanding contributions in the fields of waste to energy, renewable energy, biochar utilization, carbon capture, combustion and automotive engineering have inspired and enriched our understanding of this crucial subject. His thought-provoking insights have provided us with a deeper appreciation of carbon capture technologies and their environmental impact. We are grateful for the time and effort Dr. Murugan has taken to be with us, and we appreciate his dedication to research and education. And his remarkable academic journey, extensive research contribution, and commitment to innovation have truly set a benchmark in the field of energy and sustainability. A heartfelt thanks to all the participant faculty members and researchers who are actively engaged in this session. Your enthusiasm and meaningful discussions made this session of this FDP a fruitful learning experience. Dr. S. Murugan sir, may we continue to collaborate and innovate in the pursuit of sustainable energy solutions. Thank you, sir.
Thank you, sir. Thank you, Murugan
one and
sir.
all. Again, thank
Thank you, Professor.
the organizers,
Organizer.
Professor
Thank you, sir.
Chinnapandi and Professor Purushothaman.
Thank you, sir.
Thank you very much.
Thank you
Thank
also.
you.
Thank you.
Thank you once again
No, okay.
Thank you,
Thank you, sir.
Thank
for
you.
passionately listening. Thank you all.
Yes.
Thank you, sir. Thank you so much.
Thank you, Professor.